In section 5, we're going to talk about congruent angles. So when we talk about congruent angles, there are angles that have the same measure. And then we also have arcs on the figure, which also indicate which angles are congruent. So if I look at the image over here, my two angles are angles N, M, and P, and R, M, and Q, which both have a measure of 25 degrees, so I know they are congruent. And then if I also see I have these two arcs here, which if I didn't have their angles being 25 degrees, then I would know by those arcs that they are congruent. So if I'm writing two angles are congruent, I say angle NMP is congruent to angle RMQ. So it's the same symbol as when we were talking about congruent line segments. So in our first example, we want to state whether each pair of angles is congruent, and if so, write a congruent statement, which is what we just did in the definition. So if I look at my first example, I'm given that both angles are 47 degrees, which is the same measure, which means my angles are congruent. So when I write my congruent statement, I say angle DAB is congruent to angle HOT. Angle HOT. It is important that you have the angle symbol there so we know we are talking about angles instead of something else. In B, we want to know if angle TAF is congruent to angle BIG. Well, if we look, we have our arc symbols here, and there are two, which is fine. You can have three arcs as well, but they both have two arcs, which means the angles are congruent. So I can say angle TAF is congruent to angle GIB. So in our second example, we want to find the value of x and the measure of one angle. So we aren't given the measure of the angle, but if we look, each angle has an arc, which means they're congruent, which means their measures are the same. So I know 6x plus 2 has to equal 8x minus 14, since they have to be the same measure. And then I just solve the equation for x. So I get my variables on the same side, so I'm going to subtract 6x. So we have 2 equals 2x minus 14. Then we're going to add 14 to both sides, and we get that 16 equals 2x divided by 2, and we get x equals 8. So that is one part of the problem. We solve for x. But we also want to find the measure of one angle. And the reason why we only have to find one angle is because they're congruent. So whatever the measure of angle ABC is, angle FBD is also the same. So let's find the measure of angle ABC. So the measure of angle ABC is equal to 6x plus 2. And now that we know x, we can plug that in. We do 6 times 8 plus 2. 6 times 8 is 48 plus 2. So we have the measure of angle ABC equals 50, and then we do want to have the degree symbol since every angle has the same unit for right now, which is degrees. And notice how I put this little M out in front of my angle symbol? That indicates we're talking about the measure. So the measure of angle ABC is 50 degrees. Next, we want to talk about an angle bisector. Similar to a segment bisector, it is, in this case, it's a ray that divides an angle into two congruent angles. So if a segment bisector is a segment that divides an angle into two congruent segments, an angle bisector does the same for an angle. So if we look at our example here, if PQ is the angle bisector of our angle RPS, then it tells us that angle RPQ is congruent to angle SPQ. And we do have our little arcs here that also indicate that the angles are congruent. So we're going to use angle bisectors to do a couple examples. So in the first example, we know that angles QP and QR are opposite rays, and that QT bisects angle RQS. So in our first example, we're given the measure of angle RQT is 6x plus 5, and the measure of angle SQT is 7x minus 2. We want to find the measure of angle RQT. So let's label what we're given. So angle RQT is 6x plus 5. So you have 6x plus 5. And the measure of angle SQT is 7x minus 2. We want to find the measure of angle RQT. So RQT. So we're going to use the fact that QT is an angle bisector, so we know that the two angles we're given, their measures are the same. So we know that 6x plus 5 is going to equal 7x minus 2. So I'm going to subtract 6x from both sides. So we get 5 equals x minus 2, then add 2, and we get that x equals 7. Now that we know what x is, we can find the measure of our angle. So remember, the measure of angle RQT is 6x plus 5. So plugging in 7 for x, we get 6 times 7 plus 5. 6 times 7 is 42 plus 5. So that tells us the measure of angle RQT is 47 degrees. And it also tells us the measure of angle SQT is also 47 degrees, since they are the same. So using the same image in B, this time we want to find the measure of angle TQS. If the measure of angle RQS, so our whole angle, is 22a minus 11, and the measure of angle RQT is 12a minus 8. So this time we have 12a minus 8, and then the whole angle is 22a minus 11. So we aren't given the measure of angle TQS, but remember, QT bisects the angle, which means they're congruent. And I know that when I add the two angles together, I should get my entire angle TQS. Sorry, my entire angle RQS. So I can use that to solve for my angle measure. So these two angles are congruent, so both of them have the same measure of 12a minus 8. So we know that 12a minus 8 plus 12a minus 8 is going to equal the whole angle 22a minus 11. So first we're going to solve for a. So combining like terms on the right side, 12a and 12a is going to give us 24a. Negative 8 minus 8 is going to give us negative 16 equals 22a minus 11. So I'm going to subtract 22a from both sides. So we get 2a minus 16 equals negative 11. Next we're going to add 16. And we're going to get that 2a equals 5, then divide by 2, so we get that a equals 5 halves. And I'm going to go ahead and leave it as a fraction. So now that I know a, I can find the measure of angle TQS. So we're not given anything about the measure of that angle, but it is congruent to angle RQT, which means it is also 12a minus 8. So the measure of angle TQS is going to equal 12a minus 8. So now I can plug in 5 halves, so 12 times 5 halves minus 8. So I left it as a fraction because I can do 2 steps. I can, instead of doing 12 times 5 and then dividing by 2, I'm going to do 12 divided by 2, which is 6, and then multiply it by 5, which gives us 30. So we get 30 minus 8, and we get the measure of angle TQS equals 22 degrees. So in our last example, we're given that YU bisects angle ZYW and that YT bisects angle XYW. So we have 2 different angle bisectors, which means we have 2 different congruent angles. So first, YU bisects angle ZYW, which means angles ZYU and WYU are congruent. Then we're also given that YT is a bisector, which means angle 1 and angle 2 are congruent. So 2 sets of congruent angles. So in our first example, we're given the measure of angle 1 is 5x plus 10, and the measure of angle 2 is 8x minus 23. We want to find the measure of angle 2. Well, we know those 2 angles are congruent, which means 5x plus 10 is going to equal 8x minus 23. So first we solve for x, so we're going to subtract 5x. So we get 10 equals 3x minus 23. And we're going to add 23 to both sides. We get 3x equals 33. Divide by 3, and we get that x equals 11. So now that we know x, we can find the measure of angle 2. The measure of angle 2 equals 8x minus 23. So we plug in 11 for x. So we get 8 times 11 minus 23. So we get 88 minus 23. And we get the measure of angle 2 equals 65 degrees. And one thing I should note about both of these examples is we can't assume the pictures are drawn to scale. So angle 2 may not actually be 65 degrees, but we do know it is an acute angle, so that much holds true. In our last example, we're given the measure of angle WYZ is 82 degrees, and then the measure of angle ZYU is 4R plus 25. We want to find R. There are a couple different ways we could solve this problem. I'm going to do both. I'm going to do the easier one first, and then I'll do the one that takes a little bit more time. So since we know YU is an angle bisector, it splits our angle in half. So the easiest way to find R is since we know the measure of the entire angle is 82 degrees, the measure of angle ZYU, which is half, is going to be 41. So we know that 4R plus 25 has to equal 41. And that's going to be the easiest way to find R. So we're going to subtract 25, and we get that 4R equals 16, divide by 4, and we get that R is 4. So that's probably the easiest way to solve for R. The second way we can solve for R is using the fact that angles ZYU and WYU are congruent. So they both have to measure 4R plus 25 and add to give us the 82 degrees. So we can say 4R plus 25 plus 4R plus 25 is going to equal 82. So this is another way to find R. It will give us the exact same angle. It's just going to take a little bit more time. So combining like terms on the left side, 4R and 4R is going to give us 8R. 25 plus 25 is 50 equals 82. Subtract 50, and we get that 8R equals 32. Divide by 8, and we get r equals 4. So again, we still got the r equals 4 just like we did, but it just was a couple bit more steps, but it's still a valid method to solve for r.